This is section 2 of chapter 1, use segments and congruence. This is for honors geometry. Previous years I used this as a quiz, not real sure what we're going to do this year, but this will serve as a little review of the 4 postulates that we had in section 1. So notice how it's fill in the blank. Maybe we'll start with the second one down. It's probably a little bit easier to get started with. 2 lines intersect at a blank. So when you have 2 lines and they cross, where do they cross? They cross at a point. 2 lines intersect at a point. Next one, 2 planes intersect at a blank. Think about the floor and the wall. Do the floor and the wall touch? How do they touch? What do they touch at? Their intersection is a line. 2 planes intersect at a line. Next one down, any 2 points are blank. Sometimes people say any 2 points are on a line, and that's okay. I would accept that, but we're looking for one term. What means on a line? Any 2 points are collinear. Okay, so now that we went over those, I think the top one will make a little more sense. Any 3 blank points are blank. So it's that other postulate. Any 3 non-collinear points, those are points that aren't in a line, are on the same plane or coplanar. So it should be any 3 non-collinear points are coplanar. Meaning any 3 points that aren't in a line, you can put a plane through them. That's all that means. Okay, so that served as a review. This does also. These are your shorthand ways to name our building blocks. 1 letter, that's a point. 2 letters you can use to name a line, a segment, or a ray. Notice how the notation changes depending on which one you're talking about. Also remember that you can reverse the order when you name a line and a segment, but you can't for a ray. If you're going to name a plane, you're going to use 3 letters. You don't put anything in front of it or anything above it, just 3 capital letters. That refers to a plane. And the reason that works is if you think back to the postulate we just talked about, any 3 non-collinear points make a plane. That's why you use 3 letters to name a plane. Okay, now the new thing that we're going to look at today is just a capital A and a capital B with nothing in front of it, nothing above it. What does that mean? That's what we're going to look at. Okay, so we've already looked at postulates. Here's how it's actually defined. In geometry, a rule that is accepted without proof is called a postulate or an axiom. A rule that can be proved is called a theorem. And you're going to see a lot of theorems this year. Postulate 1 shows how to find the distance between 2 points on a line. So that's what we're going to look at next. Actually, there's postulate 1. We're going to do an example first, just to see if you can kind of figure out what postulate 1 is going to tell you. Okay, so here's example 1. They give you a line, and notice how on the line there are 2 points that are named. So if you're just looking from point A to point B, you could call that a segment. And that's what they're asking you. How long is segment AB? Notice the numerical values underneath those points. Those are called coordinates. So those points live somewhere, like on a number line. So A lives at -6, B lives at +12. And since this is a number line, we can kind of figure out how long that segment is. Take a second and think about it. How long is that segment? Okay, hopefully you've figured out that this segment has a length of 18 units. We're going from -6 all the way to 12. It might help you to put a 0 somewhere in between the A and the B. Maybe put a 0 in there and call that point C. You got to go 6 units to get to 0. And then you got to go another 12 units to get to point B. So 6 and 12 together give you 18. That's one way to do it. I'm sure some of you have already thought of the other way to do it. If you're at B and you want to go to A, it's also 18 units. What you could do is take those coordinates, 12 and -6, and you could subtract them. 12 minus -6 gives you 18. That's another way to do it. Okay. Third way doesn't really apply to this one because I don't have the little tick marks for every single coordinate. But if this actually were a number line, you could count the units yourself. You could count 18 little spaces from A to B. We'll look at that as we go. Okay, so that example kind of leads you to this postulate, hoping you were able to figure that on your own. And if you couldn't, it's okay. It's going to make a lot more sense now that we understand what this ruler postulate is. Okay, so we have points A and B. We have the coordinates for A and B. The distance between points A and B, it's written as just an A and a B together. That's that new thing we were looking at earlier. Remember back on this slide here, the AB at the bottom, what does that mean? Well, it means a couple things. It means the distance from A to B, or it means the length of segment AB. So write that in there. Distance from point A to point B, or length of segment AB. We're going to use both of those interchangeably. That's what that means. That's the measure of a segment. So your answer for that is a number. Okay, and notice how it tells you how to calculate that. That's what this ruler postulate is for. Take your coordinates and subtract them. It's going to give you a number. And what you need to do is take the absolute value of that number. Remember, that's the positive value of that. So absolute value is always positive. When you're measuring something, it's always in a positive length. You cannot have a negative length segment. Coordinates can be negative, but the lengths of the segments must be positive. Think about that for a second. How tall are you? Are you 6 foot tall? Is anybody negative 6 feet tall? Probably not. If you're going to have a positive length, anything that you measure has a positive length. Okay, so we're going to look at some examples using this ruler postulate in the next video.